Okay, so we have been given a question right here. A spider moves upwards after letting out a strand of web. Determine the initial upward acceleration of the spider. Mass of the spider 3 times 10 to the power minus 6. Let me write it down. The things that have been given to us, right? Given is basically mass, right? Mass of spider, which is basically 3 times 10 to the power minus 6 kg. We have been given Earth's electric field. Earth's electric field, which is basically 120 V by M, and we have been given the magnitude, which is basically of magnitude of charge, right? So magnitude of charge on a strand of web, which is basically 3 times 10 raised to power minus 7 coulombs, right? Minus 7. Yes. So magnitude, if you don't know what does the magnitude means, magnitude means just the value, right? It hasn't been given positive or negative, just the value only, right? Some people don't know what does magnitude means, so it's for them. Okay, so we know that spider is acting like a basically point charge. So we know, because as we can see, Earth is there, right? Earth is acting, for example, Earth is acting like a sphere, right? And we have spider, which is very small, acting like a positive test charge, negative test charge, right? So basically we're going to use the formula of the test charge, which is E is equals to F by Q, right? And we know basically that the force on the spider is basically going upwards, right? But the weight is down, weight doesn't change, right? So we have to remember that the force on the spider is basically going up because it's repelling, right? But the weight is always down. So let me calculate first the force, right? Let us calculate the force from this formula, right? I'm gonna write this formula right here. So F is equals to, which we have 120 times the charge, which is 3 times 10 raised to power minus 7, right? So we get this value as 3.6 times 10 raised to power minus 5 newtons, right? So now we have the next thing, which is basically resultant force, right? So resultant force is basically, because force is going up, my weight is going down, so I need to know, like, basically what is the initial upwards acceleration. So my motion is basically up, right? My motion is positive at upside, right? So F is positive and weight is negative, right? So my force is basically 3.6 as we have calculated right here, right? And my weight is basically, which is mg, which is basically mass of the spider, which is 3 times 10 raised to power minus 6. And we know that the gravity that has been given at the end of your exam paper, which is 9.81, right, meter per second, you can say meter per second, right? So once you do all of these calculations, right, you get your resultant, which is 6.57 times 10 raised to power minus 6 Newton. This is your resultant Newton, right? So now we need the basically we need the initial velocity, right? Initial upward acceleration, my bad. So acceleration can only be get from F is equals to ma. This is our initial, right? So this is our resultant force is gonna come over here. So our resultant force is basically 6.57 times 10 raised to power minus 6. Your mass is basically 3 times 10 raised to power minus 6, and you need to find your acceleration, right? So your acceleration, once you calculate this, you have to just divide it by this value, and then you get your answer as 2.1. I have rounded off 2.1 meter per second square, right, in three significant figures, or you can say 2 decimal places, right? 2 decimal places. As we can see, the values are given in your paper is 3.00 times 10 to the power minus 6, the mass of the spider, right? So it's 0.00, right? So you have been given in 2 decimal places, so you also should write in 2 decimal places, right? So this is your answer.